Hi, everyone. Let's take a look at number 6 on page 408. Part A, calculate the vector product for vector A, which equals to 0, 1, 1, and vector B, which equals to 0, 5, 1. Step number 1. Vector product means you got to take the cross product of these two vectors. So if you think about vector A, which equals to 0, 1, 1, and vector B, which equals to 0, 5, 1, you can cross them. And again, when you cross two vectors, there's so many rules that you can follow, and I'm going to show you one possible method. So, to cross vector A with vector B, the first step is you cover this first column and you take the product of 1 and 1 minus the product of 1 and 5. So this means it's going to be 1 minus 5. So again, let's take this away. It's going to be 1 minus 5. Now, likewise, if I look at this last column right here, I have to cover the last column, take the product of 0 and 5 minus the product of 0 and 1. So again, if I look at this carefully, this is going to be exactly 0 minus 0. And if I look at the middle column, it's going to be the exact opposite. So I cover the middle column, I take the product of 1 and 0 minus the product of 1 and 0. Again, this will give you exactly 0. So if you clean this up a little bit, 1 minus 5, of course, that's going to be negative 4, 0, and 0. So that's the cross product of A and B. Part B, explain geographically or geometrically why it makes sense for vectors of the form 0BC and 0DE to have a cross product of the form A00. So in part A, we basically gave you one of the many cases. And in part B, they're asking, what about the general case? How do we understand this? So it really goes back to that dual mindset that we've been advocating, right? So can you solve this algebraically, which is what we just talked about? And can you understand this graphically? So here's the graph that I want to show you. And it's very doable, by the way. You got this. So when you think about part B, the first thing I would say is you can draw a diagram and you can basically graph X, Y, and Z, which looks roughly speaking something like this. This is going to be X, that's going to be Y, and this is going to be Z. And again, here's the rough and ready kind of scale. I'm thinking about the two vectors, A and B, that was given to us. I'm also thinking about the general format. So if I have to go back to A to give you an example, it's going to look something like this. So I think about 1, 2, 3, 4, and 5. I also think about 1. And if you go in the negative region, that's going to be the cross product in the moment. So I'm going to put a 1 here as well. Now, here's the first idea. If I think about vector A, that's going to be 0, 1, 1. That means I go right by 1, up by 1, and the vector is going to look, roughly speaking, something like that. When I think about the second vector, B, and again, I'll label this as A, B is going to be 0, 5, 1. So I don't move on the x-axis. I go right by 5, then I go in the z direction by 1. So this is going to be vector B. So you can try this on your own. Notice in both cases, and this is the key here, x equals to 0. So this really means you're thinking about two vectors on the same plane, also known as the YZ plane. So what that means is if you think about the cross product of A and B, it's basically going to point in one of two cases, right? So depending on your frame of reference, it could be pointing in the positive direction or the negative direction on the x-axis. And this is the reason why when you cross anything in the form of 0BC and 0DE, it's going to give you A00. And again, A could be an element of real numbers. So depending on the actual numbers, it could be in the positive or negative direction of the z-axis. I hope this makes sense.